Hello. When you have two vectors directed at an angle 90 degrees towards each other, that vector is known as the perpendicular vector or the orthogonal vector. Now we want to solve these kind of vectors, and we want to add the vectors together. Let's say we have the coordinate system, and then in this coordinate system, let's take let's say a vector of 5 Newton. 5 Newton moves towards the positive x-axis, and then is directed another vector of about 12 Newton, okay, is directed towards the positive y-axis. And then you are asked to find the magnitude and the direction of this vector. Now you need to understand one thing, that the vector here formed a triangle. All right, it formed a triangle. Let's bring back this 5 Newton outside here, and then this is theta, which indicate the direction of the vector. We're going to use your famous Pythagoras theorem, which is used in solving triangles. So I have that c squared is equals to a squared plus b squared. Now, a squared is 12 raised to the power of 2, b squared is 5 raised to the power of 2, and then I know this to be 144, and then this to be 25, and then when you add them together, c is equals to, this will be 169, and then when you do that mass, you're going to be having 13 Newton. All right, that is the magnitude. But to find the direction, you need to be conversant with the SOHCAHTOA. I'm going to use that for the theta. Theta is definitely the tan inverse of the f of y axis over the f of x axis. Now recall that this is the fx. Recall that this is the fy. So let's do that in our calculator. Okay, let's do that in our calculator. Okay, sorry. We have the tan inverse of the f of y, which is 12 over that of 5. All right, let's do that immediately. Shift tan, f of y is 12, and that of the f of x is 5 Newton. So we're having 67 degrees. So theta here is 67 degrees. Now, this is 13 Newton at an angle of 67 degrees. And this is the 5, 12, 13 triangle. Let's say we have another vector. Leave this one over there. Okay, or let's clean it up so that you don't get confused. So we have another vector. All right, sorry. Let's say we have a vector moving as the direction towards the negative x-axis at 3 Newton. Another vector moving towards the positive y-axis at 4 Newton. Now, this is the positive y-axis, negative y-axis, positive x-axis, negative x-axis. Now, if you look at these vectors, the two of these vectors is going to form an angle 90 degrees to each other. So they are going to form a triangle. So we're still going to use that, that formula from Pythagoras. So we have a squared is c squared is equals to a squared plus b squared. Now, what's going to be my c squared? For my c squared is equals to 4 raised to the power of 2 plus 3 raised to the power of 2, and then this 16, and then this is 9. Then c is equals to the square, 16 plus 9, that's going to give me 25. And then the square root of 25, c is equals to 5. So I have 5 Newton, write that well, 5 Newton. Now, directed at what angle? Now, for the angle, tan inverse theta is equals to the tan inverse of the f of y over the f of x. Now, look for this. The f of y is 4 Newton. So the answer is the tan inverse of 4 divided by 3. Let's do that in our calculator. Let's do that. Okay, the tan inverse, shift tan, of 4 divided by 3. I'm having 53 degrees. So what I have here is 53 degrees. 53 degrees. But I need the reference angle that is directed towards the positive x-axis. All right? The reference angle that is directed towards the positive x-axis, here is 0 degree, here is 90 degree, here is 180 degree. And if my positive, if I need an angle which is directed towards the positive x-axis, I need to know that the angle is suspended or inclined at the second quadrant. And if it's at the second quadrant, what I'm going to be doing is 180 minus theta. And that will be 180 minus that angle there. And that angle is 53. So as to get my reference angle relative to the positive x-axis. So what will I do? 180 minus 53. So I'm having 127 degree. That's what I have here. So what I have is, over here will be 127 degree. So that's how to solve for this. It has a magnitude of 5 Newton and directed at an angle of 127 degree. Now let's solve another one. Let's say we have two vectors. Let's say a vector is moving, one vector is moving at this direction at about 8 Newton, and then another vector is moving at this direction at about 15 Newton. All right, now you are asked to find the magnitude and the direction of the vector. Now, this vector, of course, is perpendicular, so it's going to form an angle 90 degree, and this is my theta. Remember that a triangle, the missing side of a triangle is found using the Pythagoras theorem. So let's go back to the Pythagoras theorem, which is c squared is equals to a squared plus b squared, which is 8 raised to the power of 2 plus b raised to the power, plus 15 raised to the power of 2. So c is equals to the squares of 8 raised to the power of 2 plus 15 raised to the power of 2. Let's do that straight up in our calculator. Make sure your calculator is in degree mode. 8 raised to the power of 2 plus 15 raised to the power of 2. I'm going to be having 17 Newton. So I have here 17 Newton. Now, what's the angle? Now, to find the angle, theta is equals to the tan inverse of f of y over the f of x. Now, this is my f of x, and this is my f of y. So I have that the tan inverse of f of y, which is 15 divided by 8. Let's do that in our calculator. Shift tan of 15 divided by 8. What I'm going to be having here is a very poor number, 0.032. Very poor, 0.032. So what I have is 0.032. Okay? Now, but I need an angle that is relative to the positive x-axis. Recall, this is the positive x-axis, and this is 0 and also 360 degree. This is 90, this is 180, this is 270. I need an angle that is relative to the positive x-axis. An angle that is relative to the positive x-axis will be the 360, which will be, because this is the fourth quadrant, which will now become, for the fourth quadrant, it will become 360 minus theta. Now, what I'm going to do is 360 minus this guy. Let's approximate it to 0.33, okay? Because 0.33, all right? Now, let's do the math. So we're subtracting it from 360. So I'm going to be having 360 minus that will give me 359.96. 359.96. So my new angle here will be 359.96 to the minimum, okay, 0.97 to 2 dps. All right, now this is what I have here. Now over there, you notice that the angle is in the fourth quadrant. So I need to find the angle relative to the positive x-axis. Now let's do for the last quadrant, the third quadrant now, which is the one we have not done. Okay, let me fill in. So we have at an angle 359.97 degree. That magnitude of these two vectors is 2 Newton at an angle of 359.97 degree. So let's solve another one. Let's say we have this. Okay. Stay focused. Let's say we have this. We have a vector that is moving towards this direction, and that vector is, let's say, 7 Newton, moving towards the negative x-axis. Another vector, let's say 24 Newton, moving towards the negative y-axis. And you're asked to find the magnitude of this vector. Recall that the perpendicular vector or the orthogonal vector, they are at angle 90 degrees to each other. So let's use the famous Pythagoras theorem again. So that c squared is equals to a squared plus b squared. Now we're going to be having 24 raised to the power of 2 plus 7 raised to the power of 2. So that c is equals to the squares of 24 raised to the power of 2, 7 raised to the power of 2. Just follow the same rule. We don't have much time. Okay, we don't have much time. We would begin to get you the answer. But let's do it straight up in our calculator. So we have 24 raised to the power of 2 plus 7 raised to the power of 2. That's 25. So that C is equals to 25 Newton. Now, what's the angle? For the angle, we need to know that theta is equals to the tan inverse of f of y over the f of x. Now, the tan inverse of f of y, this is f of x and this is f of y. The tan inverse of 24 divided by 7. Let's do that. Shift tan 24 divided by 7. That's going to give me 73.739. I'm going to make it around approximately 73.74. All right, but I need an angle that is relative to the positive x-axis. That's what I want. An angle that is relative to the positive x-axis means that we are in the third quadrant. And if we are in the third quadrant, the angle will definitely become 180 plus theta, which is 180 plus 73.74 degree. Let's do that. This is going to give me 253.734. So I have the reference angle that's directed towards the positive x-axis is now 253.74 in 2 dps. Now this is going to be 2 Newton at an angle 253.74 degree. All right, 253.74 degree. So this is all we've got for you in this video. And if you have a question, drop it in the comment section. If this video has helped you at all, give it a thumbs up, and you're always welcome to follow for more. Have a great day.